Statistics for returns. To statistically describe a series of returns, you would typically use measures like mean, the average return, standard deviation, also called volatility, and potentially other descriptive statistics like median and range to understand the central tendency and dispersion of the returns within the dataset, providing insights into the overall performance and risk profile of an investment over time. Key points about describing a series of events. Mean, or average return, represents the average return of all data points in the series, giving a basic understanding of the overall performance. Standard deviation. This measures how much individual returns deviate from the mean, indicating the level of volatility or risk associated with the investment. Other descriptive statistics: median, meaning the middle value when data is arranged in ascending order, useful for identifying outliers, and range, the difference between the highest and lowest return, providing a basic measure of spread. Important considerations. Time frame. When analyzing returns, it's crucial to consider the time period being examined, as returns can vary significantly depending on the time frame. Risk-adjusted returns. To compare investments with different risk profiles, consider using risk-adjusted return metrics, like the Sharpe ratio, which takes into account both the average return and standard deviation. Two methods to be discussed are the arithmetic and the geometric mean. The key difference between the two is that the arithmetic mean is calculated by simply adding up the values in a set and dividing by the number of values, while the geometric mean takes into account compounding by multiplying all the values together and then taking the nth root, making it more suitable for calculating average returns over time, especially when there are significant fluctuations in values. The geometric mean will usually be lower than the arithmetic mean in such situation. Key points about the difference. The arithmetic mean is a simple average, just calculated by summing all the values and dividing by the number of values. The geometric mean, however, calculates the average by multiplying all values together and then taking the nth root, where n is the number of values. Now, when you might want to use each, the arithmetic mean is suitable for situations where the fluctuations in values are not that significant. The geometric mean, however, is more appropriate for calculating average returns over time, especially when there are large fluctuations or compounding is involved.